PCH, can you guys believe it? It's our first ed puzzle of this unit, Unit 5. It's the first ed puzzle of the new year. And I'm really excited for this one, especially because this unit is all about trig, and trig is so cool. But it's really important to establish a strong foundation. And so, of course, during class today, we talked a lot about right triangle trig, and how we can determine sine, cosine, tangent, all of our trig functions based on what we know about right triangles. In this ed puzzle, to get us ready to talk about the unit circle tomorrow, it's important that we understand some of the specifics of special right triangles. And I know that you guys talked about this last year in algebra. And so there are two different types of special right triangles that you guys talked about last year. One of those was a 30, 60, 90 triangle, and the other was a 45, 45, 90 triangle. And of course, when I'm talking about those numbers, I'm talking about the measures of the angles within the right triangle. And the reason that these were both special situations for us were because the sides of these triangles are related to each other in very specific proportions that never change when you have these angles. When we are talking about 30, 60, 90 triangles, give us more space here, hopefully you remember that the side opposite from our 30-degree angle, we'll say that that measure is equal to x. If the length of that side is equal to x, then we know our hypotenuse of this type of triangle is going to be 2 times x. In the same way, the side adjacent to our angle of 30, or if you want to think about it as the side opposite the angle of 60, is going to be root 3 times x. And so when we're thinking about it in the context of this triangle, which has a hypotenuse of 1, let's try and figure out what the lengths of these other sides are. And so we'll start out by setting this hypotenuse equal to 2x, because again, x is going to be this side that's opposite our 30-degree angle. And so if we solve for x, we solve for this side. When we divide both sides by 2, we get x is equal to 1/2. And when we think about it, if we have our side x is equal to 1/2, double that is going to be 1. And that's going to be the length of our hypotenuse, which we see is the case here. Lastly, in order to get this last side opposite our 60-degree angle, we are just going to multiply this side here of 1/2 by root 3, so that we get root 3 over 2. Great. In the same way, when we have a 45, 45, 90 triangle, I'll draw again here. If our hypotenuse, well, no, I'll start with the sides first, actually. If we have our sides, which of course, because both of these angles are 45-degree angles, both of the legs or the sides of our triangle are going to be the same length, and we'll call that length x, then that means the hypotenuse of this special triangle is going to be root 2 times x. And so for this example here, if we have a hypotenuse of 1, we can set that equal to root 2x, divide both sides by root 2, in order to find x, which is 1 over root 2. Now, of course, we've talked about this before when we've talked about radicals. We don't really like to have radicals in our denominator just hanging out there. And so a lot of times you'll see this written as root 2 over 2. And you get that when you multiply 1 over root 2 by root 2 over root 2. And that way, again, you do not have a radical in your denominator. Awesome. We are going to do some examples tomorrow in class, I guess Monday, that you'll see here, as well as answer this question about what we notice when we solve for some of these trig ratios when they have to do with special triangles. Now, the really cool thing, and why we're even talking about these triangles in the first place, is because they are the foundation for the unit circle. And I know when we talk about the unit circle, sometimes it makes some of us cringe. It's like this big, crazy, difficult, confusing thing that we spent so much time over. But I want you to trust me, and that this really isn't a crazy, hard, difficult, stressful thing to master. When we talk about it during class, you'll really get to understand it and how it's created, to the point where you won't even need to have a unit circle with you in order to apply and use some of the information that it provides for you. And so how the special right triangles pop up is you'll see that from the origin, we can draw triangles that have a side that's along our x-axis with our radius, creating our hypotenuse, with one of our angles touching the side of our circle. And you'll see that there are a bunch of triangles here that have been drawn continuously. And the reason these triangles are drawn as they are is because these triangles represent each of our special angles. And so when we're looking at this triangle, we see that we actually have a 30, 60, 90 triangle. And based on what we decided in the previous tab, we knew that if we have a hypotenuse of 1, which is always going to be the case in your unit circle, that's what makes it the unit circle, is that our radius, or when we're drawing triangles, our hypotenuse is always equal to 1. The opposite side from your 30-degree angle is going to be half. And the side adjacent, the side that lines up with your x-axis here, is going to be root 3 over 2. When we think about trying to label this point on our circle, what do you think that point's going to be? Hopefully you got something along the likes of root 3 over 2 for your x value and half for your y value, because our sides represent our rightward movement and our upward movement. In order to get from our origin to this point here, we go over root 3 2 units, and we go up half a unit. That creates our point. The sides of our special right triangle are going to create our point that lies on our unit circle. And that's going to come really in handy, especially when we get to talking more about the unique features of the unit circle in class. You'll see that you can find another special right triangle with your central angle of 30 if you keep following it along your unit circle. You'll end up finding 4 of those very triangles. All right, one last thing I really want to point out. I know this is kind of hard to see. That's better. Okay, so I just recreated what we just had above. You'll see the y and x axis I've marked in pink, as well as redrawn our 30-degree central angle triangles here in blue, as well as copied down our point of root 3 over 2, comma 1 half. And so when we're looking at this, again, we notice that we don't just have this 30-degree angle as a central angle for this triangle in our first quadrant, but we also have one in our second quadrant. The really cool thing about that is, if you think about it, these sides, again, are going to be the same. This is going to be, we have a hypotenuse or radius of 1, which makes this side opposite our 30-degree angle 1 half. And the side that lies along our x-axis is root 3 over 2. But we're going on negative on the x-axis. And so when we're trying to come up with this point, we're going to have a negative root 3 over 2, comma, 1/2. And if we want to think about this in terms of counting around the unit circle, and remember when we're thinking about our unit circle along our axes, we're always starting here at 0 degrees, and we're going to be counting around this way, perhaps continuously. All right, to the point where we get to all the degrees in a circle, which we talked about on, what was that, Wednesday, is 360 degrees. The reason we're counting this way is because, remember, when we're thinking about how our quadrants are listed, this is quadrant 1, this is quadrant 2, 3, and 4. And so when we start in quadrant 1, and we count through quadrant 2, 3, and 4 in that order. When we do that, and I've listed this on our unit circle down here that I'll go back to in just a second, but when we start at 0 degrees, of course, on our coordinate plane, we know that those axes create a 90-degree angle, and so our positive y-axis is going to be 90 degrees, our negative x-axis is 180 degrees, our negative y-axis is 270, and again our positive x-axis becomes 360 degrees. When we go back to what we have written here, you'll see that we have quite a few lines that are drawn, and those refer to the other special angles that we have in our special triangles, whether it's 30 degrees that we've already drawn here, 45 degrees, or 60 degrees. And those continue to happen throughout each quadrant. And so we're thinking about counting. If we're starting at 0, we count it by 30, so we get 30 degrees. We have a 45 degree line that's created by our 45 degree special triangle. And of course, another 30, 60, 90 triangle, but this time with our 60 degree angle being our middle angle. We can think about that and almost going backwards from our negative x-axis, which is equal to 180 degrees. If we subtract 30 from that, we get 150 degrees. If we subtract 45 from 180, we get 135. And lastly, when we subtract 60 degrees from 180, we get 120. And again, if you want a view of this that's a little bit easier to see, you can see these different triangles actually drawn here. We see this 30, 60, 90 triangle drawn with our 30 degree angle as our central angle. We see this 30, 60, 90 triangle drawn here, but instead of our 30 degree angle being our central angle, our 60 degree angle is actually our central angle. Our 30 degree angle is down here. And we'll talk about this more during class tomorrow and Monday as well, so no need to stress if it seems very complicated right now. And one more way to make it seem really not that complicated is, again, if we're just drawing our unit circle from scratch, as long as we start at the axes, we can really easily create this. And if you notice, let's just add 30 degrees and keep going. Start at 0, add 30 degrees. We get 30. 30 plus 30 is 60. 60 plus 30 is 90. 90 plus 30 is 120. 120 plus 30 is 150. And 150 plus 30 is 180. That's covering just about every single special angle we have except for these two that come from our 45, 45, 90 triangles. And so we'll keep that in mind as we go into our lesson for today. All right, see you guys tomorrow.